In a previous video, we looked at solving an equation system using the matrix inversion technique. Another way of solving an equation system using matrix algebra is to use Cramer's rule, and we want to look at that procedure today. So let's go back to the old equation system we used earlier. The first equation in that system was 3y minus 4x equals 4. And the second equation in that equation system was 2y minus 2x equals 3. And again, to solve this equation system using matrix algebra, just like before, let's write out the A coefficient matrix, the X variable matrix, and the D matrix of constant terms, which we did previously. So let's start out with the A coefficient matrix, which is 2 by 2, since we have two equations and two unknowns. And as you recall, the first row elements were 3 and minus 4. And the second row elements in the A matrix were 2 and minus 2. The X variable matrix is going to be a 2 by 1 column vector. Since we only have two unknown variables, the first variable in the first column for each equation is y, and the second variable in the second column for each equation is x. And finally, we have the D matrix of constant terms, which again is going to be a 2 by 1 column vector. We put the constant term from the first equation first, and then the constant from the second equation as the second element, which is just 3. Now, again, we need to see if we have a unique solution to this equation system. So let's start by looking at the determinant of A, which again is 3 times a minus 2, which is minus 6, minus a minus 8, which is plus 8, which is equal to plus 2, which is not equal to 0. So again, we know that we have a unique solution that does exist to this equation system. Now, how do we find that unique solution to this equation system, a unique value of y and a unique value of x? Well, this time, instead of using the matrix inversion technique and finding the inverse of A and getting the cofactor matrix of the A matrix and the adjoint of A and all of that, to use Cramer's rule to solve this equation system, we need to form the A1 matrix and the A2 matrix. So here's how we do it. The A1 matrix is the same as the A matrix, only we replace the first column in the A matrix by the D column vector. So again, I'm just going to go back to the A matrix, but to get the A1 matrix, I replace the first column of the A matrix with the D column vector, and then put in the remaining elements of the A matrix into the A1 matrix. So again, we have minus 4 and minus 2. Now let's form the A2 matrix, which is similar to the A matrix, only now we replace the second column of the A matrix with the D column vector. And all of the other elements of the A2 matrix will be the same as they are in the A matrix. So the first column remains 3, 2, but now we're replacing the second column in the A matrix with the D column vector. That's all we have to do. Okay, now we need to look at the determinant of the A1 matrix and the determinant of the A2 matrix. So that's relatively straightforward. The determinant of the A matrix is 4 times a minus 2, which is minus 8, minus the other cross product, 3 times a minus 4, which is minus 12. So this is going to be minus 8 plus 12, which is equal to a positive 4. What is the determinant of the A2 matrix? Again, it's the difference between the cross products. 3 times 3 is 9, minus 2 times 4 is 8, which is equal to 1. Okay, after that, we can go straight to Cramer's rule. And here's what Cramer's rule says. The first variable in our X variable matrix, which was y, according to Cramer's rule, is the determinant of the A1 matrix over the determinant of the A matrix. The determinant of the A1 matrix was 4. The determinant of the A matrix, as you may recall, was 2. So this gives us the answer y equals 2. To find the second variable in our x variable matrix, which was x, using Cramer's rule, that is simply equal to the determinant of the A2 matrix over the determinant of the A matrix. The determinant of the A2 matrix was 1. The determinant of the A matrix was 2. And those are your solutions, which are the same as we got before using the matrix inversion technique to solve the equation system.